Okay. Just to tell everybody I'm recording this session. Is that okay? Just so we can share it afterwards. All right. So just be mindful of what you say. Obviously, if you don't want it recorded, that would be great. All right. So to be completely transparent, didn't really know what we were supposed to be talking about today. So I'm gonna do my best, and hopefully you guys will enjoy. So I think the reason I'm here is to talk to you about my experience in medical imaging as an AI researcher. Okay, I'm a data scientist. So first and foremost, to full disclosure, you'll see here Notebook LM. So I use Notebook LM. Who uses Notebook LM? Who knows what is Notebook LM? Okay, if you don't know, you should know, and you should be using it. All right, so I'm just telling you right now, if you missed the boat for like who has like the free version for Google? Gemini, right? There was a free 1 year pro for all university students. I think it's closed now. All right. So if you didn't get that, that's a shame because it's fantastic. And Notebook LM, I don't know if you were using Gemini recently, but it used to make slides. It made slides for you, with backgrounds and images and schematics. It's fantastic. And they broke it out into Notebook LM. So this is what used to be in Gemini. It's amazing. So use it. I can't say it enough. So I'll show you what it did. And literally, well, all I did was put in some topics that I thought were interesting for today. And I asked for the slides. Of course, you'll see I added in some of my own slides. Sure, it's not all Notebook, but just for fun. Okay. So whenever you see this white background like this in Notebook LM, this is literally straight from Notebook LM. I did not make any changes to it. Okay. Very dramatic title, Data Science at the Edge of Life and Death. That was Notebook LM. That wasn't me. I don't think I would have thought of saying that, but hey, it's kind of catchy. I like it. All right. So first, let me acknowledge my affiliation. So first and foremost, my primary affiliation is in the Department of Medical Imaging in the Tamardy Faculty of Medicine. I'm the director of data science there and a researcher. I'm also an associate prof in the Department of Statistical Sciences, as well as the director of EDIIA and a prof in the Institute of Medical Sciences, which is the graduate student unit for the Tamardy Faculty of Medicine. I'm also a faculty affiliate for Schwartz Reitzman Institute for Technology and Society. Has anybody heard of that? Yeah. It's a cool little, well, it's not little anymore. It's a pretty big group. Basically bringing tech to society. And I'm part of it, as you can imagine, for AI, right? No surprise. Faculty fellow for community engaged learning. Has anybody done any community engaged learning here? So community engaged learning means that you partner with the community and it's reciprocal in terms of their needs and their learnings and your needs and your learnings for education. So for instance, you would partner with, a company, let's say, and do an internship with them, stuff like that, but it would be formalized as community engaged learning. So I do a lot of that. I'm also an associate member at TMU. Do you guys remember what it was called before? So it's changed, right? So now it's the Toronto Metropolitan University. I work in their School of Graduate Studies for engineering. And then the last one is I'm a visiting professor at the University of Costa Rica, and that is for my work in global health, which I will talk about later. I have to give disclosures. So inevitably, because I'm an AI and I take an interest in startups, I am connected to industry. So I have two of my own startups. This one's exited. This one is still current, SelfDex. I work with pharmaceutical companies, Sobi, Novo Nordisk, and a steel company in Japan, Nippon Steel. And I sit on advisory boards for companies. So the disclosures means that if you're going to put up your hand and share a secret, just be aware that you would potentially be enabling me. That is literally the reason for disclosures when you're in this space. Okay. It's a bit silly because I teach. If I wasn't a professor, then there would be a risk, but I wouldn't steal students' ideas. That would be pretty, bad for me, for my integrity as an academic. But that's the reason for disclosures. Okay, so how I got started. You guys are gonna say, what the? Especially your age group for sure. Um, that's my computer. What? Right? The VIC 20. So the Commodore VIC 20 was, 5 KB, 5 KB of RAM, 5 KB RAM. I'll say it again, 5 KB of RAM. Okay. So, and everything that was safeguarded, saved, was on a cassette, magnetic tape cassette. Okay. So you can imagine you didn't get very far with the VIC 20, but that's what got me interested in programming, which was in BASIC. So then you'll say, I went to computer science. I did not. I don't have a degree in computer science. I don't have a degree in statistics. What? What? What do I have a degree in? Well, my first graduate work was in botany here at the University of Toronto, where I studied cyanobacteria as a microbial physiologist and biophysics. So it was a lot of fun, but I kind of realized, computer programming was kind of cool, and that's the way to go. And I brought a lot of my basic programming skills to the lab. It was a wet lab. And I just started programming and created a whole bunch of utilities and a whole bunch of fun stuff. And I said, you know what, I'm going to get into computer programming. And I did. And I actually left computer programming. I left academia to work in industry as a computer software engineer in COBOL Kicks, which then went into Java. So the big and mainframes, what used to be called mainframes, the big computers. Anyway, that's how I got into computers. So why am I talking to you today? I love this quote, and it's kind of funny. I'm at MIT. So Edward Fredkin from MIT states there are three great events in history: one, the creation of the universe; two, the appearance of life; the third one, which I think is equal in importance, is the appearance of artificial intelligence. I think he was kind of being funny, right? But the thing is, it so happens it's actually pretty close to the truth. So why is that? Because AI is a disruptive technology. You don't even have to ask if it's a disruptive technology. It is one. If you don't know what a disruptive technology is, which is a market term, it means that generally over time, which is your x-axis, you'll have a performance increase of tenfold in less than 10 years. Okay? So there's your disruptive technology, right? And that's AI. We're already there. So it's no surprise that it's so important. Now I'm going to zip through these pretty quick. This is just the boring definition of intelligence, right? The ability to acquire and apply knowledge and skills. Boring. If you had to remember how to describe AI or machine learning from today's lecture, just remember that. Store, compute, learn. That's it. Do you remember that? You're good to go. You can explain that to anybody really quick, no matter who's listening. But if you want to understand the learn bit a little bit more, François Chollet from Google, very well-known guy, he states, intelligence is the efficiency with which you acquire new skills at tasks you didn't previously prepare for. I couldn't agree more. Okay. Intelligence is not skill itself. It's not what you can do. It's how well and how efficiently you can learn things. So there's the machine learning aspect that we're going to, Ernest is going to walk you through today. But that's the important aspect of the learning. Okay. So now we're back to the notebook LM slides. So, if we bring in medicine, right? What's important in medicine? Well, I'll ask you guys, what do you think? Why is medicine ripe for artificial intelligence, machine learning? Yeah.
There's so much data.
There's a lot of data. There's not much.
There's a lot.
Yeah, absolutely. A ton of data to use. Exactly right. What else?
Human error is a big factor.
You wouldn't be very popular in any of my talks or the audiences in the Faculty of Medicine. Be careful on that one. Sure. I mean, there's room for improvement. How about that? Right? Okay. Room for improvement. But what else would be more important in terms of for artificial intelligence and machine learning? So you definitely need data, no doubt. What else do you kind of need for it to be useful? Yep.
Oh, no, I was just gonna say, overworked employees, so artificial intelligence could be helpful.
To help employees.
Yeah, just reduce their workload and make it.
Sure, sure. I mean, I think that's right across the board. That's not necessarily just medicine, right? Or healthcare. But what else do you need for AI to be useful? I think you were first.
It's the predictive aspect of AI to like be
Yep.
able to detect.
Yeah, prediction key, and we're gonna go over that. Excellent.
Yeah.
But
Speed is important and like speed consequences.
but what do you need? What do you need for machine learning to be of value to Ernest, who's a computer vision engineer? What is required for him to want to use machine learning? Just because he has a lot of data, does he have to use machine learning? Who's the statistician? Who's in statistics? So do you guys agree with me? That only machine learning gives you accuracy? Yeah.
Costs.
Man. Come on, man, you guys are missing the big one. What's all this stuff up here? That Notebook LM was trying to share. What does that look like to you with that kind of data? So there's the predictions. Excellent. In order to get a prediction, what if you guys are statisticians, right? Let's say, just for fun, all men and all women are identical. They're all clones. All of them. Okay? All right. What happens to your job as a statistician?
Super easy.
Well, I guess it's beyond easy. Are you needed for inference? Not at all, correct? Because there's no variability in the data. Okay. So now, let's say there is a lot of variability and there are many variables. What does that provide to your now task? Is it easy anymore? Why is that?
There's a lot of uncertainty.
Sure, there's a lot of uncertainty derived by your inability to make sense of it. So it's complexity. You look to machine learning for complexity, for help with complexity. If everything could be solved by a t-test, do you need machine learning? No, you don't. If comparisons are really easy, if prediction is really easy, right? Can you do prediction from a t-test? No. Can you do prediction from a t-test? What is a t-test? You guys thought you were going to get away with no stats, eh? So wrong. So what is a t-test? It's a special case of the ANOVA, right? T-test is actually an ANOVA. That's a special case. It's only 2 levels. So if you have an ANOVA, let's extend that further. Can ANOVA be linear regression? Absolutely. It's just different math, but it gives you the same answer. Correct? And if you're doing linear regression, what are you doing? Oh, prediction. Huh. So then what's your predictor? It's a group variable. Am I wrong? So if you have very easy math, do you need machine learning? No. So that's where this is starting to make sense. Why would we consider machine learning? Well, because we don't, we have a more complex problem than the mean. Right? If you know the mean, then you know the difference in the mean. You're going to be predicting based on the difference in means, right? So you're basically saying if it's this or it's that based on the mean value. Is the mean value a predictor? Yeah, it is. Could you predict the weight of the next person to come in this room? How would you do it? How would you predict the weight, the body weight of the next person coming in the room?
Yeah, average plus or minus something like that.
You just take the mean of everybody in the room. That's your prediction. Is it a good prediction? If you have a normal distribution? Yeah, the mean represents the mode, which represents your most frequent number, correct? In your distribution. So is that not a good prediction? Yeah, exactly. So then I don't know who mentioned it, but they said, oh, we need better accuracy. So now we have a problem, right? Because if you actually wanted to predict the mean accurateness, or I mean the weight of the next person coming in the room accurately, you're going to need more than the mean body weight of everybody in this room. Immediately you can say, well, there's age, there's going to be sex, there's going to be eating habits, there's going to be exercise habits, there's going to be health, there's going to be, right? All those things, those are all going to be lumped in together. To do what? To do predictions. So in what we're talking about today, we're talking a little bit more about imaging, right? And the imaging involves pixels. So in that case, now we need to have infrastructure or analysis that's going to provide you the ability to deal with all those pixels and all that, multi-dimensionality, right? Very complex problems. And so there's what I just talked about is the difference. It's not a difference, they're together, right? But understanding classical statistics versus machine learning. Does that sound good? Yeah. So the tricky bit with the t-test example is, you try and simplify things, but it's not perfect, right? Is t-test comes under inference, right? You're testing a significant difference between means. But in machine learning, you're more interested in prediction. Okay, so you want to predict the value that's coming in the door. So those are the other differences that you need to keep in mind, that if you have a machine learning problem, more often than not, your interest is in prediction, not testing. And the reason for that is, do you get a p-value with machine learning algorithms? Not normally, right? You can boost your app and do a bunch of fun stuff to see if two different answers are the same or not. But ultimately, it's not a test. It's a prediction. Yeah? Okay, so this one I'm just gonna cover quickly. So who makes up the data science space? That's you guys. So there's basically 3 domains, but this, Notebook LM decided there'd be 4, right? But really there's kind of 3 domains. So what would they be? Stats math, that's an important domain. And computer science would be computer science and engineering, correct? To be fair to engineers. And then the medical domain would be the content, right? The expert domain. It added machine learning here just to be special, But machine learning, as you know, is their algorithms. They come under models if you're talking about statistics. So they would probably fall under stats, right? They could fall under computer science and engineering as well. And depends on how you look at it. But it would almost be an intersection between those two, would be your machine learning. Okay. So what's important in these domains? Are any of the domains more important than others? No. Good answer. The content expert is always excluded. If you talk to statistics, they say machine learning and AI was born in statistics, right? If you talk to computer scientists, they say machine learning and AI was born in computer science. Talk to math, they say, oh, hey, it was us. It was us. Talk to physics. Oh yeah, physics, man. That's where AI was really born. So everyone's claiming AI, except for these guys, which is the content. And yes, maybe they didn't develop the algorithms, absolutely. But can you do any of this fun without them? No, because they're the only ones who understand the data. And you can have all the fun you want doing machine learning, stats, all that stuff. If you don't understand the data, you're wasting your time. Okay, so very important to always include your content experts. All right, and so that's where I sit, by the way. So I don't have a degree in statistics. I don't have a degree in computer science. My degree is actually in medical sciences. Okay, but I took an interest in stats and computer science. But I've been working in medicine for, I won't even tell you how many years. So I create that bridge. Okay. And so now Notebook LM is talking about the dangers of the black box, which we'll talk about a little bit later. I'm just being mindful of time. I want to make sure Ernest has all of his time. Okay, so let's just get through the type A data science. Let's get to this. So, oh, it didn't come through, sorry. So I want to get through this because now that you know what makes up a data scientist, and you're saying, oh, it's very important to have content experts working with you, right? I want to now share with you where you should be thinking AI should be, okay? Because most of the time, audiences like you guys immediately think AI is in your laptop, right? It's you programming. You're in control. You own it, right? You are the engineer. You are the statistician. You're the whoever you want to be who owns AI, right? Nobody can do it without you, and you're a rock star, right? So then naturally you're going to think, well, I'll ask you guys. So where's the most impactful application of AI, let's say in healthcare? Since we're here for healthcare. Where do you think, oh my God, I'm going to win the Nobel Prize? Where do you think that's going to be? What's the first thing that pops into your head right now? Boom.
Cancer.
Cancer. Did you say cancer? Wrong. Perfect. What else? Who else? First thing that pops into your head. So cancer was one. It's already taken. Yep. Early detection of what? Cancer? Okay, well, you guys are together. Okay, give me another one. Yep.
Age reversal.
Age reversal. Okay. Okay, age reversal. I love it. What else? Healthcare here. What else are you going to be applying your brains to? Yeah. What's that?
Pandemic.
Pandemics. Nice. Pandemics. Okay, what else?
Accelerated drug discovery.
Drug discovery. That's huge.
Brain regeneration.
Brain regeneration. I love it. Now we're cooking. Now we're cooking. Just what do you think this is? Why did I put this up? Who's that? That's me, right? Okay. Okay. Who's that? Who do you think that is? My mom? Who's that? Okay, so that's the leader of an indigenous community in Costa Rica. She's one of the leaders, and she runs the community. She's the boss. All right. So why am I showing you this picture? Well, why would you care about some small indigenous community in Costa Rica?
Because they're underrepresented in data.
They actually have no data. No, really, they don't. They all use a phone, but they don't have data to share. So, but what would I be doing there if I'm doing brain regeneration, cancer detection? Why would I be doing that? What am I doing there?
The smallest things matter a lot too.
So in this case, interestingly, it's not the smallest thing. I'll go back to my question. What's the biggest impact that AI is going to have in healthcare? Yes, access to care. It's going to be really simple AI that's going to improve access to care to those who are not privileged. Think of it. And it's not because I want this to happen. I'm telling you this is going to happen. Because which countries do you think are the most engaged in AI on the planet today? Give me the number one country. Do it. Who is it? Yes.
USA, China.
USA. China, yes. Who else? So China is number one. Who's two? Who's in the top five? India. What other countries? Saudi Arabia. Oh, what? Why? Because they want to get off gas. They have a lot of money. They want to invest. So Saudi Arabia. What other countries? All countries that are pretty much called LMICs, low middle income countries, are at the top of the list. Because they realize this is how they're going to provide healthcare to their country, their population, for less money by using AI. So China is leaps and bounds ahead of everybody because they have such a large population, India as well. They have such large populations. They cannot afford to offer healthcare like we have in Canada to all of their population. So they are working on AI like just wow, crazy. United States is only like 4 above us, and we're near the bottom. Like I can't remember where we are. We're like 19th or something in the world. United States is maybe 15th or something. France is below us. Why is France even less enthused about AI? Because they're a socialist country. Everybody has amazing coverage in healthcare in France. Because you pay for it through your taxes, but they have amazing coverage. So they're like, why do I care? But no, I'm being very serious. We're privileged here. So we don't care if it takes literally 6 months to 2 years for a mammogram to be read in Costa Rica. So if you're a woman, you get your mammogram done, it will take minimum 6 months and up to 2 years to get an answer back. Wouldn't you like to get that answer a little sooner? But we don't care here because we get it back within weeks. Tops, like the longest is a couple of weeks. So we're like, we don't need AI. Does that make sense? So the biggest impact of AI is going to be that. It's going to be access to care, absolutely guaranteed. And so that's what I'm working on. And so this one is just to make you guys feel jealous, because this is me out in the rainforest collecting data, right? And I'm like you guys, I'm computer geek. My whole life, right? So this is an opportunity for me to get out there in Costa Rica and actually walk around, get data. So I'm just making you feel bad. But I'm also trying to encourage you to apply what you know to do that. Okay, so this is just software that we put together for the community. If you want to know more about it, you can ask me. And this is now I'm easing into our work. So this is the group here. These are medical students, and these two are the physicians for ultrasound. I do a lot of work in ultrasound, and we're going to be doing thyroid assessment in these communities, online, offline with a phone. Okay, and obviously, and that's it. So now we give you a hands-on. All right. That Ernest is going to take over. So before Ernest is the boss, time for a few questions. Are we good? Are we on time? Questions? Yes.
Did you say that your work mainly focuses on like responsible and fair? Yeah.
So yes, yes. So you're clearly, because that's an interest of mine. Yes. That's all I do now. Just because it's from my stats background, actually, I have I've always had a particular interest with data heterogeneity versus homogeneity, right? The distributions. And that's kind of what was my interest as a stat. Not was, is an interest of mine in stats. And so inevitably bias, is a huge thing for me in algorithms, right? Biased algorithms based on the data that it was trained on is a particular interest of mine. So yes, absolutely. That's a big interest of mine. And for you guys, that's going to be a really big area, right? And you should all be at the forefront of that, right? Because you are statisticians or data scientists or whatever. Who's in math here? Is anyone just math? Right, mathematicians, right? So, you're the ones that are going to say, hey, wait a minute, should we be implementing this algorithm? Or have you tested this algorithm? Or how did you test this algorithm? How did you validate this algorithm to make sure that it's fair, as you say? Because that's the biggest problem is the majority. Where's the majority of data that's being used for AI training? Where's it from? That's a good answer. That's good, but no. So where in terms of reach?
Developed countries.
You gave the right answer already. It's China and the USA. China by far and away, and the US. And so then that creates a bias, right? So the data is very biased, especially if it's coming from the United States, tends to be more white, male, all that fun stuff. Europe as well. And so when I bring down algorithms to Costa Rica, do they apply? No, because they're all from Costa Rica, so they're different. So I'm working with the government, and so what we need to do is retrain all the algorithms with local data. Then they're fair. Good question. Yep.
Is the current like industry and system incentivizing fair AI or is it incentivizing flashy stuff?
That's a very difficult question to answer. The reason for that is no, it's a problem. So currently, money is incentivizing AI. Right, just to be very blunt, makes sense, right? Makes sense. And it's not a bad thing. I have a startup, right? Don't get me wrong. I work with pharma, right? So it's very incentivized by money, and so that's a problem. So what do we need? Regulation, and that's what's coming, and that's what's going to force fair and equitable AI. So it's not going to be pharma because what they're driven by is sales. And I'm not saying this in a bad way. I'm just being realistic. That's what drives pharma companies. And so sales are driven by success of their drug in patients, right? And that's a good thing. But is it fair? No, because there could be subpopulations that the drug just doesn't work for. And so what needs to happen is regulation. And that's exactly what's happening, is that you'll have regulatory, just like drugs, it will be regulated that you can't just deploy software out into the wild without having it validated to make sure it's fair. Yeah? Okay. Other questions? Ernest is going to take you through some hands-on stuff, and then you can ask questions as we go through and whatever. You can imagine, I'm being very transparent. How often do I code anymore? Like actually code? Unless it's like a fun project with my kids, and my kids are older than me actually. But unless it's doing that, I'm not coding anymore. Why? Because I have someone who's way better than me at coding. Right? And it's not just Ernest, I have a few other people, but Ernest is particularly good at coding, particularly good at machine learning. So why would I say, oh, Ernest, I'm going to do it and see if I can outcode you? It's silly, right? I wouldn't do that. So that's the reason you have an expert here who's going to walk you through this. You want me to swap it off? Okay, so I will just disconnect, right? Correct? I'll leave this connected so it's recording. Yeah.
And then maybe you can mute you.
I will, absolutely.
Cool profile picture.
You guys,
Yeah.
who knows who that is? Yeah, you guys watched the movies? It's from the 80s, man. So you know it's really fun. And I'm like, hey, whoa, it's from a movie. It's Doc Brown, And then they Google it, I think it's funny, but if you don't know who that is, just Google Back to the Future. There's a big movies in the 80s, and he was a kind of a mad scientist from that movie. So we good now, Ernest?
I think so, yeah.
Okay, so just make sure you're unmuted
Yeah,
And
I
you're-
am. I'm in the
and you're sharing your
meeting.
slides.
Yeah,
And
yeah.
amazing.
Okay. Um,
Yes.
disclosure slash confession. I forgot to take my keyboard, so I'm using my system as a tablet, but it should be fine. Anyways, so I was telling you that when we were planning for this workshop, we asked the hosts to send us a starter code, and they kindly did. And the plan was to build up on it, but then we thought we could make it a little bit more fun. So we thought about talking about weaknesses and strengths of, sorry, you don't see me there. Strength and weakness of vibe coding, the disasters you can get because of using the latest version of programming tools. So what we did was that we took this starter code. No, let's go through it. You can download this whole repository. The link is there on the board. We will share all these slides and recordings after on this GitHub repository as well. I took this, I put it on my Google Drive, and then we can take a look at the content we have. Great. So first cell, just installing Kaggle Hub. Kaggle Hub for does everyone know what Kaggle Hub is? Is there anyone who doesn't know what Kaggle Hub is? Yeah, okay, perfect. So Kaggle is a platform for hosting machine learning competitions. In my opinion, it was one of the game changers that captured a lot of attention for machine learning and brought in a lot of funding. So how it works is that there are some, nowadays it's a big thing. There are free materials, there are tutorials, all those things. But the main thing is that there are competitions. There's a prize for every competition you join, either individually or as a team. And then there's a timeline, you submit your solution. The solution is evaluated on some sort of unseen data. And then the winners are announced, they get the prize, the codes are shared, the discussions are open, all those things. So this Kaggle Hub library gives you a lot of facilities to be able to interact with that platform. And the main thing, especially today for us, is just to download some of the Kaggle datasets. So that's what we are doing there. And then we are working with this specific, sorry, my screen is not that smart. With this specific chest X-ray pneumonia dataset from Kaggle. So first, we just download this dataset. As I said, I'm on my tablet today, so it's a bit annoying.
Anybody have a Surface? And lend Ernest your
Yeah.
keyboard?
Well, I'll do my best. We'll see. Sorry about that. Anyway, so we first download this data set. Good thing is that I've already done that, and all cells have output, so we can just go through the codes. Importing other libraries we need. And then as you can see, there are some to-dos and notes on this notebook because it was just the starter code. We were supposed to complete it. Let's first take a look at the content of this dataset in terms of the file structure directories. And actually, that's the very first thing you do in every programming project you have, just to get yourself familiarized with the structure of the data you have. So you're using OS, all your programmers, so you know what that is. It provides you with some tools to interact with your files. And then you get this list there to get the list of directories and files you have. Under Kaggle input chest X-ray pneumonia, we have chest X-ray. It's a directory. Under that, you have val, test, and train here. And then let's just take a look at train. So if I extend the path, you see that there is pneumonia and normal. So these are two classes of chest X-rays we have in this data set. And the idea is to train a model that uses chest X-rays as input and then predicts or identifies if the X-ray is normal or a pneumonia case. Right away, with this definition, what is the limitation of this data set? So we have two classes. We have pneumonia and normal. What is the problem with this set? How different is it compared with real world problems? Let's say you want to deploy this at a hospital. What is the problem? In real world, you have many more scenarios, many more abnormalities. So it's not gonna be just normal or pneumonia. What if it is COVID? What if it is cancer? There are many more situations that are not covered in this data set. So that's one of the things that you need to appreciate and pay extra attention to. Those are the major obstacles we always have for deploying the machine learning models into practice at hospitals and clinical settings. And the list is just infinite. There are so many different things that make biases in your pipelines. Okay, so the next thing we do, and again, thank you, the hosts. These are their codes, not mine. The next thing you do after you get yourself familiarized with the structure of files and directories you have is to load the data. And that's very important. I think it's a personal opinion. One of the major differences between someone who is a junior programmer, especially in healthcare, and the senior programmers is that senior ones have experience to make the data loaders extensive and comprehensive so that they can deal exceptions, missing data modalities and data entries. identify outliers right at the data loading level, red flag any bias there. So that data loading needs a lot of experience, and I would highly recommend you read about data loading in healthcare. It is a little bit modality specific. So if you work with X-rays, it's a different story compared with when you work with MR. And also it depends on the context, the hospital or clinic that you work with. There is this whole data culture thing that you need to be familiar with. Sure.
Can I just ask, from your experience, how much time do you think you spend on the data, cleaning, preparing, loading in a project versus modeling? What do you guys think? Just from your own personal experience. Just think of the time you've spent, the totality of a project that Ernest has just explained. How much time is spent on prepping the data before you actually start modeling, tuning hyperparameters?
20 to be
So 20%
80%,
doing what?
loading and cleaning and stuff.
Okay. Who is it? You guys agree with that? So actually, that's very interesting.
It should be the other way.
It is literally the other way around. I'm very serious. It's about 80% of your time is spent cleaning, prepping, data loading, and 20% is modeling. So what's the fun part of being us? Modeling, right? It is. Modeling's fun. That's the sexy part of a project. But just be prepared, because you're delusional. 80% of your time is doing what Ernest has just pointed out, which is so crucial. So when he said, and it's kind of funny, the reason it twigged me is because he kind of said, oh, the data stuff, but be prepared, okay? Be ready for that, because you are going to be disappointed if you think it's going to be 2080. It is not ever, not ever.
I've been lucky with both assistant props and clean data.
No, it's true.
Yeah.
That's very true. You actually could be privileged in that sense that, the projects that you've been brought on, it's already been done, or the data's already clean, or it's Kaggle stuff, or it's whatever. You come and work for my company, it's not going to be that way. Or if you come and work in a complex, scenario like what Ernest is explaining, it's not really. Anyway, sorry, Ernest.
These days I'm working on a project. It's with echocardiographs, ultrasounds. And the data, of course, is real world data coming from a hospital. But then the hospital is a bit new to the whole concept of AI and analytical projects. So everything is super duper messy. And even right now, I don't have any ideas how I can deal with some of the mess and be able to plug in my previously trained pipelines to that. But anyway, so that's the hardest part of the job always. And you're lucky if you have people who are willing or forced to handle that part of the AI pipeline development projects. Okay, so after data loading, we have a plot. In the next notebook, we have the outputs from these. It's, as I said, just the starter code. But the idea of this plot, let me see what the idea was. Anyone from the host? Yeah, so showing just one image and its label, that was the idea. And then we get to the data exploration part. We plot one of the examples. As you can see, it's one of the pneumonia cases. We have, again, some of the to-dos. We go for model building. We use neural networks, especially convolutional neural networks. I'm not going to go through all the details because you guys already have some programming background. And if you have any questions about these concepts, first of all, there are tons of courses and resources online because neural networks are not new anymore, CNNs are not new anymore. And second of all, if you still have any specific questions, you can contact us. We'll be helping you. The idea, because the title of the workshop is medical imaging using CNNs, let's just go through one of the CNN we have. The idea of CNN compared with conventional neural networks, feed-forward neural networks, is that you have some convolutional layers at the beginning. It enables you to identify patterns regardless of their location in the image. Because you have this sliding window mechanism in CNNs, that's a bit, well, not a bit, it can be a game changer in some context. It enables you to identify or learn differentiated features throughout the image regardless of their location. So that's the first thing you get out of it. The other thing is that it saves some number of trainable parameters in the network for you, and that helps you with avoiding overfitting. Usually you start with some convolution layers, and here, because we are working with X-rays, X-rays are 2D images. So what you need is a 2D neural net. Now, if you switch your focus to images that are 3D by nature, for example, if you work with MR, if you work with CT, these are by nature 3D, and of course, in those cases, you would need conv3D. There are some techniques called 2.5D, and there are different variations of algorithm for them. As you can imagine, you can break a 3D MRI into its slices. So if you do that, then you can handle a 3D volume using a 2D model. But then the problem is that you are gonna lose interslice information. In the case of segmentation, it has been shown that 3D models are way more effective. But 3D models are heavier. You need better GPUs with higher amount of GPU memories. So to be able to handle that and also use interslice information, you go for 2.5. There are different ways for doing that. One is that you can define a thickness and incorporate a number of slices. Another way is to have recurrent blocks to be able to remember some of the constituted number of slices, etc., etc. Anyways, what we have here is a 2D convolutional network. And then after you extract your features, you get to a fixed number of extracted numbers. From there, you usually have a fully connected layer, and that's what this is. So far, so good. We have a class to load image data, and then we get to hyperparameters. Learning rate, number of epochs are perhaps the most famous number of the hyperparameters you have in any pipeline. Again, I'm not going through all the details. These are basic. As I said, online you can find even better resources. What I'm gonna do here today is to make a base for you so that you can code more efficiently, faster, and more modern. And then, of course, you go through your epochs, which means you're gonna exhaust your training sets for a number of times, and then you do this back propagation to optimize your model to learn what you want to learn, and that's the end of learning. Then you get to evaluation, which was not implemented here. So that's the starting code we had. I'm gonna stop for a couple of minutes if you have any questions, but at the same time, we are gonna have some other things to do. Any questions so far? Sure. Oh, sure. So the way this works for, come on, move. The way it works for this type of pipelines is that you have a training set where you look at that data and you try learning how to map it to your desired label. What was our desired label? In this case, it was normal versus pneumonia. So we have just two classes. Imagine the output of this network is going to be 0 or 1. What is the input? It is the X-ray. So the mapping between this matrix of pixels of X-ray to that binary output is what I'm learning. The whole set we are talking about is called supervised learning, which means we do have access to those ground truth labels. Now, this epoch means one time you exhaust, you go through all examples of your training sets. You input the data, you get the output, you compare it with the ground truth labels, you get the error, you back propagate this error to optimize the learnable parameters of your network. For the convolutional layers, it's just a tiny kernel. Let's say if it is 3 by 3, you have 9 numbers that are being updated plus a bias. So it will be just 10 numbers in total, times the number of channels you have. And if it is fully connected, it is just the number of neurons you have plus each of them traditionally have a bias. Now, nowadays, there are tons of different versions of neural networks. Some of them work a little bit different, but this is the big picture, the conventional picture. So epoch is one time going through training set, using it to fine-tune or update the learner parameters of your network. And then we also have this learning rate, which means after you compare the output of your network with the ground truth and you derive the error, how harsh do you want to be in updating your parameters? The higher the learning rate, the bigger jumps you will have towards correcting the parameters. Okay, so was that the only question so far? Great. We're gonna stop here, switch the topic a little bit, and then go back to the second code. So there is this thing called vibe coding. Is there anyone who does not know what vibe coding is? Awesome. So vibe coding, pair programming, these are not new terms. They were there before. But then with the AI models, especially LLMs, getting better and better, the programming community used these terms, and now they're pretty much standard. They got so much attention that we nowadays see big startups dedicated to just vibe coding. and I'm gonna mention a couple of them. There is this startup. It's not maybe a startup anymore. It's very big. It's called Cursor. So you can pay, you can download their software. It will help you to do coding. And you need to pay monthly. They will make some of the LLMs available to you. The idea is that you just talk. A simple version of this, I'm pretty sure all of you have done this. A simple version of this is to chat with ChatGPT and ask it to code for you. It's pretty much the same thing with a little bit of difference. So this one is designed to be more smooth in terms of programming. So it has many capabilities. It can have a memory to, you can have some injected prompts by default there. For example, you can always have this by default included in your prompt that you say, use extensive comments in your prompt. So you don't need to ask it every time. It's always there behind the scene. And once you get the code out of your cursor or any other tool you have, it gives you well-commented code. There are many different features that these tools have. But the whole idea is that you don't need to go back and forth into ChatGPT, write a prompt, get some code, copy it, paste it to your IDE, run it, see if it works or not. Nowadays, most of them ask you to provide permission to them to access your terminal. So when they code, they check the terminal. If there is an error, they revise it automatically. So Cursor is one of them. Windsurf is another one. At the beginning, especially, NVIDIA was very interested in this one. I myself used it for a while. I still use it from time to time. It's a cool one. And these two, Cursor, Windsurf, and there are more. These are kind of model agnostic. So you download them, you pay, and then they enable you to access different LLMs. You can connect them to different models and just work with different LLMs as backends. But almost all of these are based on VS Code, which is perhaps nowadays the most popular IDE for programming. And then VS Code has a big community. It has a lot of plugins and add-ons. You can download some of them for free. Some of them you need to pay if you have ChatGPT subscription. Another thing I can recommend is to install your VS Code, install Codex plugin, and then through Codex, you log into your ChatGPT and it helps you do vibe coding. It's cool. Some people like it, and then there's a lot of debate about which one is better. Some like Cursor, some like Windsurf, some are Codex users. There is also Cloud Code, as you may have heard. All these tools are available so that you become a more efficient programmer. Now, there used to be jobs for basic programming. But right now, I'm not sure if there is any simple programming job anymore. I was watching a video from Andrew Ng, and he was telling the audience that it's a terrible advice if someone tells you programming jobs are being wiped out. when something is getting easier, more people are learning it, more people are doing it, so there's a bigger demand for it. Uh, I'm not against this idea, yes, but for sure, with a hello world, nobody's gonna pay you anymore. Because you can do it even if you don't know what programming is, you can chat with something like GPT, and after 5 minutes, you have a code working. A simple one-page web, uh, it's it's nothing. There used to be some appetite for that, but nothing left right now.
I'll just, this too good stuff to not comment on this. So I run my own company in software, right? So how we cost projects now is time and expense on cloth. I'm serious. So now when we cost, it's not how many hours of my programmers, which I don't have anymore. Yeah, I mean, I have to run a successful business, so I don't have programmers anymore. I only have a few, and I have a bunch of contractors that are all programmers. And what we do now is we cost how much prompting is going to cost us. Is that $100 on Claude or is it $1,000 on Claude? And that's it. That's how we cost projects now for software development. So Ernest is absolutely right. If you're thinking you're going to graduate and be a programmer, yes, maybe, but just think on how you're going to be. You're going to be that person who's actually going to be up from just, there is no more just laying code. You're not paid to do that anymore. Now you need to know how to put it together, how to use Cursor, how to use, whatever the company uses for you to generate what you need to do. Does that make sense? So, like, for real, I'm just telling you, I'm sharing with you how I run my company.
Thank you very much.
That's-
It was right on time. Okay, so I just opened my Chrome. I searched for anti-gravity Google. I went to this website, downloaded it for my hardware architecture. I have a Surface, mine is ARM, so Windows ARM was my option. For you, it might be a little bit different. And I'm just trying to install this anti-gravity. If you already have it, good for you. If you don't, you can use it. This is another thing I wanted to show it to you. Dr. Pascal already talked today about Notebook LM, which is a Google product, and also Gemini, which is the core brain LLM from Google. In my opinion, up to some point, maybe early 2025, Google was a bit behind. OpenAI was leading, and OpenAI models were super duper cool. And then Anthropic joined the competition. And then the last one was Google, and they did a very good job, in my opinion. The only regret that I have about Google products is that, in my opinion, it is a bit overwhelming. They have so many different things with a lot of functional overlap. You can get the same thing out of Gemini web interface that you can um, generate with something like Notebook LM, for example. Um, and then there is this anti-gravity. They have tons and tons of different tools. But anyways, so anti-gravity is the vibe coding thing, the IDE they have. And for those who are already programmers, who are already familiar with VS Code, you can see that 99% of it is VS Code. So maybe 100% it's a VS Code plus a plugin. If I can take the zoom window to the left. Great. So you see some sort of VS Code window. On the right, you have your agent. So this is where you put your prompts, and then you start coding from file. And again, I'm sorry, I don't have my keyboard today, but from the file menu, you can open a folder, and then you can go to a specific directory that you want to put all your codes and data. Another thing here that I have to highlight to compare junior programmers and experienced ones is the discipline and structure of their codes and directories. Years ago, I read a book from a four-time Kaggle grandmaster, and before that, I had this discipline a little bit, but then that was an eye-opener for me. I learned that if you structure your projects, so for his approach, it was like you have code, and then you have data, and then you have results, and then you have models. So checkpoints of your models, which are like saved files from your trained models, go to a specific directory. Results, anything you generate based on the final evaluations, etc., go to one directory. Data is always in one directory, and not just that. For data nowadays, I have a main data repository. I put all my data there, and then when I want to start my coding, I just mount that data. So it's just a symbolic link from a specific directory in my data repository to my working directory. And then we have codes in your codes, especially if you are a student, especially if you work for your PhD thesis, master thesis, the context of academia. You need to dump all the intermediate results you have. So all the predictions, make it pickle file, save it somewhere. Because chances are you publish a paper and everything looks good, and then the reviewer, especially reviewer number 2, they ask that, hey, you provided RC, you provided AUC, you provided accuracy, perfect. I also want F1. Now, if you don't have all those results, you need to go back and get inference. And for some people, they even have to retrain everything. But if you have those things, all you need to do is to open your pickle file, compute another metric, and report it. So those things matter a lot. Anyways, here file, select directory, you select your directory. The files are listed here under Explorer. And then whichever file you're working on, you open it in the main window. On the right, we have this agent, you talk with it, and you ask what you want. Going back to our case for today, and oh, sorry. Because I had anti-gravity before, I just uninstalled it before this workshop. I forgot to completely clean it. Because of the log files I had, it didn't ask me anything. When I opened it, it automatically went to the last directory I was working on, and you can see my Google icon there, which means I'm already logged in. If you're fresh, you need to log into your Gmail. That's one thing you need to do. And on the left, here at the edge, you can see I have one add-on. It is called Google Colab. If you work a lot with Google Colab, so that's another thing I'm going to talk about in a couple of minutes if I don't forget. But if you work a lot with that, you can install this add-on. It will connect to your Google Colab, and then you can directly revise your Google Colab codes from within your anti-gravity, which is cool. One note regarding notebooks and Google Colab, especially if you're in healthcare and especially if you're in Canada, clinics and hospitals are defensive in sharing data. There is a lot of concern for data privacy. You cannot work with cloud services that much. So in that case, you work with something else. It's usually your own computer, something local, something in your lab, or hospitals' HPCs. So that's number one. Number two, for real codes, I don't really like Jupyter notebooks or notebooks in general. And the reason is you can mess up in a Jupyter notebook in a cell and then go to the next cell and nothing happens. You just continue. It doesn't care. But when you have a script, if you have an error somewhere, you get an error. You cannot continue until either you solve it or you comment it out and then you continue. So that's why in real world, I highly recommend you always stick to Python scripts, not notebooks and all those things. So these two quick notes, and then we go back to if I can. Yep, we go back to Google Colab and we open vibe coding and one more thing, this prompt. So this is the prompt I used to rewrite the codes we would need for today. I said I'm teaching a course. It is Introduction to CNNs for Medical Imaging. Write a code that uses this Kaggle dataset. I provided the link. I'm working on Google Colab, make an extensive notebook that downloads and loads the data, include a comprehensive EDA, train a simple and custom CNN, do grid search on validation, monitor validation loss, and checkpoint models in each epoch. At the end, select the best model based on validation loss, provide training and validation loss plot for all epochs, then load the model for test plots rock, select my B point to get the threshold, and I provided a link to my paper. Then provide the confusion metrics and all metrics like accuracy, F1, sensitivity, specificity, etc. So that's the prompt I used. And this is the code I got from anti-gravity. So same data set, same story. It's just pure codes from anti-gravity. Any comments about my prompt? Okay, so the starting point for using vibe coding is the prompt student. I wrote this and you saw it. And this is, and as you can see, even my prompt is a super duper basic prompt. I didn't tell anti-gravity I want to write a code for this workshop. So I wrote a couple of lines. There are several points, technical points provided through this prompt. So yes, here I'm asking for a comprehensive exploratory data analysis for sure. Downloading the data, unloading, it is again general. Training a simple and custom CNN, yeah, general. Doing grid search, intermediate, I would say. It's something that the vibe coders, the LLMs behind these may lose by default. You don't know. monitor validation loss and checkpoint models in each epoch, medium to advanced, I'd say. At the end, select the best model based on validation loss. Very important, very standard, but I've seen some of these models miss that. So I'd say my prompt is not a super simple prompt. It has some technical guide for this model. So that's number one. Let's see what has happened to the codes. So right away, you see that we have some comments. That's great. If you have used ChatGPT for coding, you see that it always puts a lot of comments out. That's amazing. And then we have data loading at the beginning again. This time, it's using all the three sets we have: train, test, and validation separately. So that's something. And then we have some sort of EDA included. Come on. Yeah. So we have some sort of EDA included, which is good. At least now we know that the dataset is not balanced. That's a key for coding binary classifiers. We have more examples plotted. That's great. We have a grid, and the training does some sort of hyperparameter tuning. So we have two candidates for learning rates. We have two candidates for dropout rates. Batch sizes, fixed number of epochs is fixed and it is set to be low. And then we have three data loaders. These are great. And the training. So it trained on all the combinations of the hyperparameters. We had two candidates, and two candidates combinations would be 4. So we get the 4. We plot one example to see how the losses were over epochs, which is this. This is a very important thing to do. Keep it somewhere there. So training loss is perhaps one of the first checkpoints that you need to have for your codes. Okay, yeah, we'll be on time. Training loss is one of the first checkpoints you need to have in your codes. Ideally, you need to have a model that can perform perfectly on your training set. So this training loss ideally needs to go to 0 eventually. Based on these two plots, do we have any comments on the number of epochs we chose? So one is from training, one is from validation. Validation, even starting from the first point, was lower than training. Both are descending, and we cut everything at epoch number 5 because it's starting from 0, it goes all the way to 4. Well, anyway, so the plot for epochs, first of all, if I was going to code everything from the beginning, even this plot, I would select the grid in a way that we wouldn't have 0.5, 1.5. It would be just integers because epoch is just number 0, 1, 2, 3. We don't have anything in between, so that number 1. So it's something that anti-gravity could do better, but as you can see, it doesn't pay attention to all these tiny details. That's number 1. Number 2, this, any comments? Going back to the question we had. Number of epochs we chose 5. It went from 0 to 4, so 5 epochs. Was it enough? Was it good? Sure.
Looks like it's plateauing, so you cut it off because it takes computational power. So it's just more efficient to stop there.
Great point. So it's usually a trade-off between computational power, what you can get, and what you want to get. In medical imaging, performance matters a lot. And usually we don't care about a couple of more epochs. So in this case, I would say we stop prematurely. We would have to go for more number of epochs, and we would have to see this validation being actually plateaued after our training was going below this validation. So that's number 1. Observation number 2, my validation loss is always below training. This means the train validation splits are not ideal. So my validation split is kind of easier for the model. Usually validation should be the lowest one, then you have training should be the lowest one, then you have validation loss a bit higher, then you have test loss a bit higher. That's usually how it is. Okay, so we get to the B point, and the story about this B point, we don't have time to go over it, but the story is that these models, these binary classifiers, usually what you get out of them is a predicted probability, and then you need to map this probability into an actual label, because the labels are binary 0 or 1, and you have a prediction as a probability. The question is which threshold you want to use to cut off this predicted probability. Majority of the codes I've seen on internet, they use just 0.5 as the threshold. So above 0.5 is label 1, below that is label 0. And then there is J point, there is rock curve. If you're not familiar, go and study a little bit about it. J point is the point where specificity plus sensitivity is maximum. So you can find that point on your rock plot and then go back to the thresholds that correspond to that point and take that threshold as the cutoff for the probabilities. So that's one way. And then I had a paper that I worked on something. It's called B point. And I wanted to just show it off today. So anyways, all I did to anti-gravity was to provide a link to my paper and say, okay, take that. And it said, oh yeah, sure. B point is the intersection of rock with TPR equals to 1 minus FPR. So where sensitivity and specificity is the same, which is one of the diagonals. And that's absolutely wrong. So this is the main takeaway for today. Vibe coding is amazing. Within a couple of minutes, I got all these codes available to me. But especially because these guys have access to your terminal and to your Python environment, they go iteratively until they solve all the errors. So you don't have any grammatical error. Your codes are always going to work, almost always. Now, it is up to you to go back to all the details, especially the points that are more critical, and ensure they're right. And this would be a disaster in a real world project, because it can do something that you don't pay attention to, and it is your responsibility as a programmer to check everything that your codes are doing. So that's the main takeaway. It did that. It plotted the confusion matrix and all those metrics that I asked. Nothing more than that. I asked for accuracy of one, specificity and sensitivity, and more, but there is nothing more. Another point, and I know today was very heavy. I just gave you a lot of details. Maybe you can go back to the recordings of today, listen it for one more time, or use AI to use the transcripts and just take out some notes for yourself. But anyways, for classification, for especially for binary classification, in my opinion, you need two things. You need rock, which deals in a non-parametric way with your predictions. So that's one. And the parametric way, which means labeling the outputs, thresholding the outputs to get the actual label. In that word, you need confusion metrics. With this, you can derive accuracy of one, sensitivity, specificity, anything else you want. So that's the most complete version of evaluation, metric-based evaluation that you want. So that's this, and I'm almost done. And then we will stop for answering your questions. A couple of different things. This generate notebook, generate nb.py. It's nothing specific. It's just a Python file, anti-gravity made, because anti-gravity has access to your Python environment. It cannot directly create a notebook for you. So it first creates this, and then this is rendered as a notebook. So this is nothing. It's just what happened behind the scene to get that notebook out. And then the revised viewpoint, you're not surprised that, again, I used anti-gravity, but this time with another prompt to say, hey, you made a mistake. There was something wrong with your B point calculation. And one more thing you see is that these loss landscapes are a bit different. That's because of the randomness. We are taking stochastic gradient descent, and not always the models are going to be the same. Okay, so this time I provided, I didn't include the prompt in the logs, but I provided anti-gravity with the formula to calculate that V point for me. And when I did that, then this was the output. So it's not a simple main diagonal anymore. It is actually tilting the line to find the balance, because in this case, I had more positives. So the line is a little bit tilted above. We got this, and then we calculate the metrics we had. And we compare that with the wrong way it took before. In this case, the performance is a little bit better when you use B point, but that's not the point for today. Anyways, so this is the last version of the code we have. Everything is on our GitHub. Any questions you have right now, we are here to answer. And if there is something else left for future, feel free to reach out to us. Thank you very much.
Let me point out a couple of things that Ernest makes some great points. There's so much to talk about, right? But we can't do this in 2 hours. So one of them is that was a bit of an oddity when you have your validation under your training. It's not expected, right? So what he explains is absolutely right in terms of what can be happening. But what else can be happening here? Because he alludes to it with his B point, which is fantastic, in terms of adjusting your ROC based on the number of positives, correct? So what was he pointing towards, which is a huge concern when you're doing a binary classifier in CNN?
You would rather have, false positives than false negatives or something.
Yeah, that would be a clinical question,
Right.
but that's excellent. But just in training, what should have we been very concerned about in this data set, which the second code pointed out graphically? Yeah, bingo. Class imbalance is a big problem. So B point all that is fantastic if you can't fix it. But the thing is, if you have class imbalance, let's take it to an extreme. Let's say one of the classes has very, very few, and the other one has many, 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 many. So let's say 1 to 100. What's your algorithm going to do in order to reduce the loss? What can it do to be successful? It's a loss function. It needs to be successful mathematically.
More important to predict.
Yeah, it's just going to guess, because just by guessing, it's going to be right most of the time, and therefore your accuracy is good. Is that what you want? No, absolutely not. So that was a red flag that should have been brought up, and then we need to address, and that could have contributed to that oddness, right? But as statisticians, be very aware of that, of when we calculate accuracy, that what's the algorithm actually doing? And then just a little oddity. Have you heard of loss function and cost function? What's the difference? You guys know? Is it just you just use a different word? It's equivalent? Because it is used interchangeably all the time. So a loss function is when you calculate for one entity, one data point, and cost is for the overall. Okay, so when people say cost, they're talking about the model. When they say loss, it's for the individual calculation, right? But that's why they use it interchangeably. But I just thought I'd bring it to your attention. Okay, so Ernest only just scratched the surface, right? There is so much going on here that you need to be aware of in order to be successful. And I think what Ernest is trying to share with you is that in his prompts, he's trying to be proactive in the prompts. He's trying to be educated in the prompting so that you get the better answer. So it means that not anybody can do what Ernest does. Not anybody can do what you're going to do or what you're already doing. So remember that the important thing is to use it as a tool to improve what you do. You're not getting it to do it for you. Does that make sense? That's very important. So for instance, in education, AI is going to be part of your education from now on, but we're going to start as profs, we're going to start grading your prompting. Okay, so I let all my students use AI anytime at any level. But what I'm going to ask for when I grade is I'm going to say, hey, can I look at your prompting? Which is exactly what Ernest did, is he's showing you how important it is to correctly work with that tool. Does that make sense?
Yeah,
Very
my
important.
professors said that AI is excellent at being wrong and then explaining why it's right.
That's so awesome. That's very true. It is, right? It is very good at doing that. So you can't trust AI, right? Yeah, you have to be in control. It's a tool that you are using to do a better job for you, right? You're not asking AI to do it for you. So a good analogy, well, there's so many of these analogies, but let me give you a good one, right? So, who here goes to the gym? All right, a few of you go to the gym, right? So who does bench press? Right? Some of you do bench press, right? And you're like, I want to get good at bench press. Right? So if you went to the gym, okay, and you watched Ernest do bench press, is that going to improve your bench press? No. So that's exactly what it is, using AI to do your job. You're not benefiting at all. You're just watching Ernest do bench press and you think you're going to be good at it. No, that's not how it works. So AI is exactly the same way. If you use AI to do your job for you, then it's the same analogy. You're watching someone else do bench press for you to get healthier and stronger. Never going to happen. So the use of AI is exactly the same. So when you feel you feel yourself trying to get AI to do it for you, just remember that analogy and just say, I'm not learning anymore. Right? And then you're wasting your time and you're paying my salary as a prof. Thank you. But you're not benefiting, right? And you should be benefiting. Any questions for Ernest? You will have these questions 10 minutes after we leave the room.
Yes.
Data that would give disappear in balance. Should we balance development? Should do this? That's awesome.
Great question. There are many, many different ways. One classical one is to adjust your loss function. That's one thing. Uh, the other thing you can do is to undersample the bigger class or oversample the smaller class. A fancier one, more modern example would be to work with synthetic data to augment the data set a little bit. All these methods have cons and pros, and unfortunately or fortunately, the answer to most of ML related questions is that you need to try and error over all these options. But yeah,
Fortunately,
fortunately.
then we still have a job.
Yeah.
Looking at like the loss landscape and looking at the validation loss specifically, is it a concern when it stops decreasing and increases because of overfitting, or is that something?
Theoretically, what you need to see is that your training loss is gonna go all the way to zero. And then validation loss is gonna be a curve. When it starts going high, you identify that as a sign that, okay, I'm going to have some overfitting issues, so it's better to stop. And then again, ideally, you have the same behavior for your test, maybe just a bit higher than your validation. But all these things are theories, and I have some examples. We don't have time to go over it. Especially for medical imaging, the data is very heterogeneous and noisy. So what you see usually is a mess. Everything is just fluctuating. And many, many, many times you are just blind. And so that's always a challenge. And again, the answer is that you need to try and error.
So with applications like pneumonia classification, would you ever consider using something like attention mechanisms to see what part of the image the model is actually attending to?
Great question. So attention for those who do not know the topic is a mechanism you can implement into your pipeline. It is a 1D vector that gets multiplied to some sort parts of the image to pay attention to a specific and then makes everything more explainable. You can go back to your attention variables or parameters to identify which part of the image contributed to the decision. It is not the only mechanism that makes your pipelines explainable. There are XAI modules, there are tons of them. And even with the model that we had today, there are ways you can go back and you can see which part of the image was more important for the model to predict the output. As you can imagine, one example is just perturbic image and then seeing how different the output is based on the perturbed area. And that's how you can get some sort of mapping for this attention. Attention has been a hot topic for a number of years, and in my opinion, it will stay being hot. So it's always good to have it. Again, there is no direct answer. Again, we need to have try and error. For the sake of publication and academic work, especially these days, you need to compare it with something else, perturbation, all these things. But it's for sure a helpful thing. Whenever I say for sure, I just remember that means. Anyways, for sure.
So it's not as much of a black box going forward. We're trying to make it a little more translucent, I guess.
True.
Which is going to be law. Eventually, explainability is going to be required by regulatory bodies in order to put out software as a medical device that's going to be classified under, regulatory bodies, which would be like class 2 or above, which is diagnostic. So it is coming. It's being implemented in some countries around the world, but it's been stalled with I won't even go into the details, but explainability is going to be required. But Ernest describes that extremely well. It's very delicate, right? Because in terms of, binary classification accuracy, like performance, you don't necessarily need attention, because if you have enough data and you have the right model and it's tuned the correct way, you'll generally perform quite well and you won't need attention. But attention is great for explainability, and sometimes attention is helpful. Okay, so there's never a right answer. In statistics, we always used to joke when I was a consulting statistician, is the answer in statistics is always it depends. Any other questions? Yeah, I think we're done, correct? Awesome.
Thank you.
Thank you, sir.
Thank you.
Awesome.